Hey guys, welcome to another video. So today we're going to continue on with a nice question series of videos where today's question comes from the Extension 2 syllabus. I really like today's question. So it's from the CSSA 2023 trial paper in the topic of vectors. It's to do with a Bezier curve, which is basically a curve that is parametric in nature. But for those that have seen it, it's a spiral type question. It's a really nice one. Let's get started. Oh, actually, before we get started, if you haven't already done so, please like the video, subscribe to the channel, and tell your friends. All right, now let's get started. So the CSSA question looks like this, right? I really like this question. So let's have a look. And this was 7 marks, so, quite chunky. So reading through this question, let's do so now. An ant follows a spiral path up a cylindrical column from the point 0, 7, 0. So basically the Y value is 0, Y value is 7 and everything else is 0, right? So it slowly spirals its way upwards. The ant's position are in centimeters after t seconds is given by the vector equation, this guy, right? Now, this is important because basically whenever you see Bezier questions where it's spiral in nature, right? What's important for you to identify is usually if it's spiraling, right, there's always two of the XYZs that have sine and cos because that gives you that circular sort of motion. And the other one is usually linear in nature because it basically gradually takes you up a particular axis, right? In this case, and it's really common, right, that the Z axis, right, is basically the one that we have the spiraling action along, right? And so now, depending on which one has sine and which one has cos, the one that has sine is usually the one that is at t equals 0, that's the one equals 0. So you can sort of see there when t equals 0, right? X is 0, right? So the sine is 0. Y is equal to 7, right? And Z is 0 as well. So the spiral start test. So that's important, right? Just so we can sort of identify where the start point is. Now, let's have a look at the questions. So first question, find the coordinates of Q. So where's Q, by the way? Q is somewhere up here. There it is, up here. So find the coordinates of Q. Right, I just want to highlight that. If the vector, also the magnitude of OQ, where's OQ? So here, right? Yeah, if the vector of OQ was 25. Okay, all right, that's interesting. And then goes, how many times has the ant crossed a line on the cylinder when x equals, okay. And you know what, we'll deal with those two later. Let's deal with the first question first, right? So let's get started. So part I. Now in part I, it's basically telling you that the magnitude is 25, right? So magnitude of OQ is 25. Now, magnitude, basically, I'm going to square, so square this guy. Let me make sure that's right. So magnitude, so I'm going to square both sides. So it sort of becomes, actually, you know what? I'll do the working out first, right? So 7 sine, now it's pretty messy. Pi t on 32 squared plus, I need to zoom in to write a bit neater. Yeah, just subbing in the coordinates, right? So 7 cos pi t on 32 squared plus the z1, so t on 15 squared, and that equals to 25. Yeah, obviously I'm going to square both sides, but at the same time I'm going to expand the brackets as well. So that's 49 sine squared. Now that's nice because I know that if it's sine squared, I'm going to be adding with the same coefficient of cos squares, which means that the cos and sines go away, so 32. So that's not really neat, but plus t squared on 15 squared, which is 225, equals to 25 squared, which is 625, right? Yeah, so far so good. So just to be clear there, this guy and this guy together, right, go away. But sorry, the sine squared and cos squared goes away with the identity sine squared plus cos squared is 1. That becomes 49 plus t squared on 225. Now, what am I trying to find, by the way? I'm trying to find the coordinate of Q. Okay, that's fine, because I'm going to find the value of t. Now, t is time, right? I'm going to find the value of t where this happens, and then I'll sub t into the coordinate to find q, right? Pretty straightforward. So I can sub t into the vector equation, and then you'll find the coordinate of q, right? So hopefully this is nice. So let's see, t squared 225 minus that 576. Is that right? Guys, if you multiply it up and square it, I believe, can you check that for me? In fact, I have a calculator here. I'm just going to quickly check that. So if I did 576 times 225, and I square rooted that, that's a nice number. 360, amazing, all right? 360. So at time equals to 360, that's when it's the coordinate of q. So sub that in. So therefore, for coordinate of q, right, I'm going to sub that into the vector equation. So when you sub in 360, you go 7 sine, now 360 pi on 32. What's 360 on 32? I hope that's nice. 360 divided by 32. What's that? 45 on 4. Okay. Hoping that's nice. Let's have a look. So, but I'll do that in a sec. 360 pi on 32 and the Z one. So what's that? 360 on 15. Yeah. Okay. Oh, sorry, I forgot the I's, J's, and K's, which leads to my coordinate, right? So that's I. So get rid of that. Yeah, just to get the notation right? J and K. Yep. Perfect. Now, let's simplify this. Let's see if I can get some exact value. So we know that this guy here is equal to 45 pi on 4, which is like 11 and 1/4 pi. I'm going to minus multiples of 2 pi, and I think you get negative 3 on 4 pi, which is really good, right? So both sine and cos, right, simplify down to like 7 sine negative 3 pi on 4 plus 7, sorry, that's I, and this is cos negative 3 pi on 4, oops, and then plus 360 on 15. Oh, what's 360 on 15? 24. Okay, perfect. And then we know, right, using exact values, right, that this guy is in the, what, that's in the third quadrant, right? It's the equivalent of sine pi on 4, and so that's like root 2 on 2 negative, right? This guy would be also in the third quadrant, so that'll be negative root 2 on 2 as well. Right, so then do I have space or don't have space? No, I'll just move this up slightly so I can capture that all on the same page for me. Yeah. So then final coordinates, right, would be negative 7 pi on, sorry, root 2 on 2 I minus 7 root 2 on 2 j. Let me make sure that's right. Yep. And then plus 24. Okay. So therefore, Q has the coordinates negative 7 root 2 on 2, negative 7 root 2 on 2, 24. Let me check that quickly. Amazing. Guys, that wasn't straightforward, right? So the biggest catch there was really to equate the formula for magnitude to 25, realize that you had to find the value of t, the time when it occurs, and then sub the time into the vector equation to find the coordinate itself. I thought that was quite nice. Now, let's tackle the other two questions. So let me copy the slide. I'll delete this, don't need that anymore. All right, let's go. So part 2, how many times does the ant cross the line on the cylinder at x equals to 7? So that's this bit here, right? At x equals 7 on its journey to Q. So when it's x equals to 7, right, let's see, when does that occur? When this guy's 0, no, when this guy's 0, is that right? No, I guess I've been 7 into here. Okay, piece of cake. Right, so all I got to do for this question here is basically, the question's asking, can you tell me the times it'll take for me to have the x value equal to 7, right? When x equals 7. That's what it's trying to say, right? Because when x equals 7, that's when the ant sort of crosses at that node, right? At x equals 7. So all I'm going to do for part 2 is sub in x equals 7, right? Now, what I'm going to get, if I sub in x equals 7, I'm going to find the times when x equals 7 occurs. And then the question goes, how many times has it crossed before that? So I know that the time it took to hit Q was, that for that point there, that was t equals to 360. So then once I sub in x equals 7 and solve for t, I'm going to see how many times those times are less than 360, right? And then that's my answer. So let's have a look. So when x equals 7, right? So I got 7 sine pi t on 32 equals to 7, right? So then sine pi t on 32 equals to 1. And I know on the sine graph, it hits it at pi on 2, right? So therefore, if I inverse sine, that'll equal to pi on 2. And I'll get a few of them, right? Let's get a few of them. So I'm going to add 2 pi, so 5 pi on 2. 9 pi on 2. Keep adding 4, so 13 pi on 2. 17 pi on 2. I'll do 2 more maybe. 21 pi on 2. 25 pi on 2. Now, I want to make t the subject, right? So I'm going to divide everything by pi. So all the pi's are gone, and then multiply everything by 32. So first one, multiply by 32. I think it's like 16, right? 80. Yeah, 144. Right, that guy times it. The fourth one is 208. 272. 336. 400, etc., right? Now, I'm going to stop there strategically because I know, right? The point Q has time equals to 360. So I want all the times that are less than, so I want these ones, right? Yeah, this guy here, too big. So 1, 2, 3, 4, 5, 6. It'll cross it 6 times on the way up, right? So therefore, 6 times. Yeah, is that okay? So I like that, right? So basically, it's asking how many times does it cross the cylinder at x equals 7? Well, 6 times, because that's t equals to 360 is where Q is, and anything below that is the time other times that I want. So question 2, done. Hopefully that's not too bad. Question 2 is not too bad. Question 3. Now let's see. The ant crawls back from Q to P along the shortest possible path. Okay. Oops. Shortest possible path. Now, where is that? So if you can imagine, if I'm at Q right now, if I was the ant at Q, which I know Q has the coordinates, it's negative x, negative y, positive z. So it's actually in the sort of, what's that, 1, 2, 3, the third octant, right? The third octant over to the bottom left. So it's crawling back to P, right? So what's the shortest way? Because it's in the negative, it's probably like, I don't know, go like in a, along the arc, sort of down there somehow, right? And so it sort of makes that sort of shape. Now, the best way to visualize this, so how far did it crawl? Okay, so it wants that distance. The best way to visualize this is basically, firstly, let's look at it from the top view, right? What would it look like? So for part 3, right, the top view sort of has like, it's obviously a circle, right? It's obviously a circle. Yeah, well, let's pretend that this guy here is the y-axis and this is the x-axis, right? and this is P, right? Yeah, so basically top view right now, right? And Q is somewhere over here, right? Q is there, P is there. So if I was to look at it from a helicopter view on top, it'll try to make its way from here along the edge here, right? Now it can't go like this because it's an does actually say it's a cylindrical column, right? There's no space in between, so it has to go along the surface, right? Along the surface. So not only is it going along the surface there, if you look at it then vertically, it has to come down as well. So the best way to sort of visualize it, right, is if you sort of make this blue into like a rectangle, right? Right, into a rectangle. So from the top view, and I'll show you what I want you to see, right? You sort of see something that looks like this. Oops, too far down. Let me just move this up slightly first. Yeah, I want you to visualize like, it's like a rectangle. It sort of looks like that, where this is Q, right? And this is P, right? Basically, I've uncurved it, right? I've turned it into a rectangle, right? Where I need to go from the path that it wants to travel is this distance here, right? From here to here, along a uncurved rectangle. Now, the length of this base here, right, is equal to the arc length here, right? It's equal to the arc length there. And then I know, right, because the coordinate of Q is like, what was it? -7 root 2 on 2, -7 root 2 on 2, 24. This height here, and I'll use a different color, this height here must be 24, right? Because it equals to the Z value of its height, right? So I know that's 24. If I can get the length of blue, I can use Pythagoras to find the diagonal from Q to P directly, right? So how do I find the blue? Well, arc length, right? So with the arc length, I now need to know, because remember, what's the formula for arc length? Yeah, arc length is, L equals to R theta, right? And the radius I already know is 7, right? 7 is the radius of that circle. Now, what's the theta? So what do I know, right? I actually know what the angle is, right? I know what the angle is because it's negative. Where was it? So in part 1, yeah, -3 pi on 4, right? Because it's in the third quadrant, right? It's -3 pi on 4. Is that right? Let's see. Because this is positive x, this is positive y. It's -3 pi on 4, right? It looks a bit weird that it's going back. So I'll say negative. So we're dealing with measurements. So 3 pi on 4 there. So 3 pi on 4 is the angle to Q using my arc length calculations, right? So sorry, I'm a bit all over the shop, but maybe I'll do it over here. Let me rub this off. I'll do it down here, right? Actually, you know, just do it to the right. So L equals to R theta. So then L equals to 7 times 3 pi on 4, right, in radians, which is 21 pi on 4. Yeah, so this blue distance is equal to, so let's see, do I have any space? Yep, I'm just gonna move that slightly down, slightly lower, so that I can, I dragged the X down by accident. Yeah. So I can say this is 21 pi on 4. Yeah. So with that in mind then, if I was to uncurl the blue to make it a rectangle, the base is 21 pi on 4, the height is 24 by Pythagoras. So therefore, right, it's almost like magnitude of PQ equals to square root 21 pi on 4 squared plus 24 squared, right? And if you punch it in the calculator, I'm hoping that it's approximately, let's say, around to 1 decimal place, right? So 29.1 centimeters. And that's the answer. Guys, what a beautiful question. I really liked it because it's not easy, right? And it's not obvious. But once you sort of work through, especially part two, in this question, it's probably the easiest part. It's actually not that bad. You just need to sort of understand the context of a spiral, how it sort of repeats itself, right? And there's always one axis that it sort of goes up in. In this case, it's the z-axis. Sometimes you can spiral if the linear function is on the y or the x, it'll spiral in those directions. Guys, hopefully you like that question. And if you like the video, once again, like the video, subscribe to the channel and tell your friends. Thank you very much. See you guys later.